Now deformation of a body due to force acting on it. Now consider the body is subject to tensile stresses and P which is equal to load acting on the body, and L which is equal to length of the body, and del L which is equal to change in length, right. So due to the deformation of the body, right. So A which is equal to cross sectional area, and sigma which is equal to stress induced, and strain which is equal to epsilon strain, and E which is equal to Young's modulus, right. Now the deformation of the body due to force act on it, we have to calculate del L, right. We know that stress which is equal to load by area. This is one formula already we discussed. Now strain which is equal to del L divided by L, change in length divided by original length, which is epsilon, right. Now E which is equal to stress by strain, right. Now substitute the value of strain. So E which is equal to, right, E which is equal to P divided by A divided by del L divided by L. So E which is equal to P into L divided by del L into A. Now we want to calculate del L, change in length, right. So now del L which is equal to P L divided by A E, right. So del L which is equal to, what is that, change in length, P which is equal to the load acting on the body, and L which is equal to length of the body, and A which is equal to cross sectional area, and E which is equal to Young's modulus, right. So from that we can calculate del L, change in length due to deformation, right. So after deformation we have to measure that is called as del L, change in length, right. Now let us solve a simple problem. Let me read the problem first. A steel rod 1 meter long and 20 into 20 mm in cross section is subjected to a tensile force of 40 kilonewton. Determine the elongation of the rod. If modulus of elasticity for the rod material is 200 gigapascal, right. So 1 pascal which is equal to 1 Newton per meter squared, we know that, right. So gigapascal which means 200 into 10 to the power of 9 Newton per meter squared, right. So this is given in mm, and we have to calculate into, we have to convert this 200 gigapascal into 200 meter per second. So 200 into 10 to the power of 3 Newton per mm squared, right. So now what they are asking, determine the elongation of the rod, change in length. So del L they are asking. So what is the formula of del L? What are the data given? Length of the rod which is equal to 1 meter is given. So we have to convert into millimeter. So 1000 millimeter, right, and 20 into 20 cross section. So area which is equal to how much? 20 into 20 mm. 20 into 20 mm squared, right. And tensile force T which is equal to, P, load which is equal to 40 kilonewton. We have to convert this 40 into 1000 Newton, right. So now we want to calculate elongation of the rod del L. So what is the formula for del L? Del L which is equal to P into L divided by A E, right. So what is the value of P? 40 into 10 to the power of 3 into L which is equal to 1000, right, divided by cross sectional area 20 into 20, right, into E which is equal to Young's modulus, right, 200 into 10 to the power of 3, right. So what is the value? So solve this, then we will get so and so 0.5, right. So del L which is equal to 0.5 mm, right. This is the answer. Okay. Now let us solve the second problem. It's a very simple problem. A hollow cylinder 2 meter long has an outside diameter of 50 mm and inside diameter of 30 mm. If the cylinder is carrying a load of 25 kilonewton, find the stress in the cylinder. Sigma cylinder, okay, they are asking. Then also find the deformation of the cylinder. Del L they are asking, del L of cylinder they are asking. If the value of modulus of elasticity E, which is equal to 100 gigapascal, right? So what are the data given? Length of the cylinder is given, L, which is equal to 2 meter, which is equal to 2 into 10 to the power of 3 mm, right? Next, outer diameter is given, OD is given, which is equal to 50 mm, and ID, inner diameter, is given 30 mm, right? The load P, which is equal to how much? 25 kilonewton, which is equal to 25 into 10 to the power of 3 Newton. Then what are the data? E is also given, right? Now what we have to find? Stress. First, ultimately find the deformation, del L, right? So del L, which is equal to P into L divided by AE, right? P is given, right? L is given and P is given, L is given, area is given, area we know that, and E is also we know that. Simultaneously we have to find the stress in the cylinder. What is the what is the formula for stress? Sigma, which is equal to load by area, right? How much this? Load, which is equal to 25 into 10 to the power of 3 divided by, this is the hollow cylinder. What is the area, cross sectional area? Pi by 4 into outer diameter minus inner diameter, right? So substitute this value, then you will get sigma stress, which is equal to 19.9 Newton per mm square. Substitute all the values in mm, right? So here the data are given in mm only, so no need to convert, right? So we got sigma, right? Now we have to find del L. So del L, which is equal to, what is the value of P, which is equal to 25 into 10 to the power of 3 into L, which is equal to 2 meter. So 2 into 10 to the power of 3 in order to convert meter into mm, divided by A, which is equal to area. Substitute this value, and E, which is equal to 100 gigapascal. We have to convert that into Pascal, right? Clear? Already we discussed in the previous problem how to convert gigapascal into Newton per mm squared, right? So what is the ultimate value? Del L, which is equal to 0.4 mm, right? Substitute all the values, then you will get del L, which is equal to 0.4 mm. Clear? Next, the next problem is a simple problem. A load of 5 kilonewton is to be raised with the help of a steel wire, right? Find the minimum diameter of the steel wire, right? So if the stress is not to exceed 100 megapascal, sigma, which is equal to 100 megapascal, they given, right? If we have to convert this into what? We have to convert this into Newton per mm squared. So 100 into 10 to the power of what? 6 into Pascal. What is the value? Newton per, this is meter squared, right? 1 Pascal, which is equal to 1 Newton per meter squared. So we have to convert this meter squared into mm, right? So finally we got 100 Newton per mm squared, right? And what is the value of P load, which is equal to 5 kilonewton, which is equal to 5 into 10 to the power of 3, right? And find the minimum diameter, right? First we have to calculate stress. What is the value of stress? Stress, which is equal to load by area. What is area? We don't know, right? So stress given, stress is given, P is also given, we have to calculate area. So from that area we can calculate minimum diameter, right? So what is the value of stress? Stress, which is equal to 100, which is equal to 5 into 10 to the power of 3 divided by area. So area, which is equal to 5 into 1000 divided by 100, so which is equal to 50, right, 50 mm squared. So area, we know that what is the formula, area which is equal to pi by 4 into d power 4, right. So 50 which is equal to pi by 4 into d power 4, right. So d which is equal to, what is the value, approximately 7.98, which is approximately 8 mm, right. So solve this, you will get d which is equal to 7.98 mm approximately. So we will convert into nearby value which is 8 mm, right.